Welcome to Matematika. Today we're going to do 1.12a, transformation of functions. I divided this into two parts because I want to start with the function families and review what are the function families. I know we have gone through this in Algebra 1. There are many types of functions, and we can group them into categories, and that is what we call the function families. The parent function is the simplest form of the function in a particular family. This is a function where no transformation is have been applied or taking place. No transformation, just the parent function. One type of function family is what we call the linear function. Right? So what is a linear? A linear has a constant rate of change. Constant. Okay? And can be written in the form of f of x equals ax plus k, where x and k are variables. So what are the characteristics of linear function? The parent function of linear is y equals x. All right? The domain are all real numbers. The range are all real numbers and always increasing or always decreasing, has one x-intercept and one y-intercept. The rate of change is always constant. That is for linear. Next is an absolute value function. An absolute value function is a function that contains a variable expression and inside the absolute value bars. So it's easy for us to identify and tell that that function is an absolute value function because we can see an absolute value bar. So it can be written in the form of f of x equals a absolute value of x minus h plus k. And the parent function is y equals the absolute value of x. The domain are all real numbers, has an absolute maximum or minimum, has a vertical line of symmetry separating the increasing and decreasing intervals, 0, 1 or 2 x-intercepts, 1 y-intercept, and the rate of change is constant, negative for half of the function and positive for the other half of the function. As you can see this side right here in the graph. All right. We'll do and go over of that later on or the incoming video. The third is the quadratic function. So a quadratic function is a polynomial function, okay, with a degree of 2. So when you have a degree of 2, then you can tell that it's quadratic function. So in the form of f of x equals a times the quantity of x minus h squared plus k, where a is not equal to 0. So what are the characteristics of a quadratic function? The parent function is y equals x squared. The domain are all real numbers and has an absolute minimum and maximum, has a vertical line of symmetry separating the increasing and decreasing intervals. There is a 0, 1 or 2 x-intercepts and 1 y-intercept. The rate of change is variable. All right. As for the exponential function, a function that has a constant percent rate of change. The rate of change is constant in exponential. So can be written in the form of f of x is a times b to the power of x minus h plus k, where a is not equals to 0 and b is greater than 0. So what is the parent function there? You have y equals b squared. The domain are all real numbers, has a horizontal asymptote, always increasing and always decreasing, 0, 1, or 1 x-intercepts, 1 y-intercept, and the rate of change is constant percent. For cubic, a polynomial function of degree of 3. So when you say a function that is raised to the third power, then it is in the it is a cubic function, and in the form of a times x minus h to the power of 3 plus k, where a is not 0. So what are the characteristics? Graph looks like this in the cubic function. A parent function is x to the third power. The domain are all real numbers as well as range. There is a point of inflection wherein it changes from concave down or concave up, or there is a change of concavity. Then you can see point of inflection. Then 1, 2, or 3 x-intercept and y-intercept, and the rate of change is variable. Okay, that's the graph. As a square root function, it's a function with a variable term under the square root symbol. So it's easy for you to identify because you can see a square root symbol. So f of x is a square root of x minus h plus k, where a is not equal to 0. And how does the graph looks like? Like this on the left side. A parent function is y equals square root of x, has an end point, has a point of inflection, 0 or 1 x-intercepts, 0 or y-intercepts, and the rate of change is variable, always increasing or decreasing. As for rational function, a function that is a quotient of polynomials. So we have gone through a rational function in our previous video, and the parent function is y equals 1 over x. It has asymptotes with their vertical, horizontal, or slant asymptotes. It has a 0 or 1 or 2 x-intercept, 0 or 1 y-intercepts, and the rate of change is variable. I hope you have remembered all of this families of function, what you have learned already in your Algebra 1. All right, let's have an example. Determine the type of function represented by the table. So we try to observe our table. The input values are 0, 1, 2, 3, 4, 5. So since the x values in the table are increasing by 1 each time, and we can determine of the type of function by observing the rate of change of the outputs of the function. So we have the outputs -7, -3, 1, 5, 1, -3. Since our intervals there are increasing by 1, so they are equally intervaled. So we can determine the rate of change. So in this case, the rate of change, well, we can start with a negative 3 minus a negative 7. So that would become negative 3 plus 7. We have 4. That's the rate of change here. Okay? Then we have a 1 minus a negative 3. This. So that would be 1 plus 3. You have 4. Then we have 5 minus 1. So this is also 4. 5 minus 1 is 4. This is 4. Then we have 1 minus 5. It's negative 4. Then we have a negative 3 minus 1. We have a negative 4. Okay, let's do some inspection here. Since part of the function has, this part has a positive constant rate of change, and the other part has a negative constant rate of change, these values represent an absolute, okay, an absolute value function. That function, one of the function family. This is how an absolute values look like, since the part of the function has positive and the other part has negative constant rate of change. Let's gonna check. Let's not just say, oh, it's an absolute value function. Let's check. Let's do that by plotting the points. When x is 0, it's negative 7. So my first point is right here. When x is 1, I have a negative 3. When x is 2, I have 1 right here. When x is 3, it is 5. Okay, blow this up. 3, it's 5 right here. When x is 4, it's 1. So 4, it's 1. There. When it's 5, it's negative 3. 5, negative 3. Okay, we'll connect the points and see what kind of function, what kind of graph do we have. Let's connect these points. By looking at this, I think you can visualize it already, that you have an absolute value graph. There. There. All right. So this is an absolute value function. Okay, let's have question number 2. You are given a table. Okay. Our input values are 0, 1, 2, 3, 4. So if we try to observe, they are having an interval or increase by 1. But let's observe the outputs. Observing the outputs, we can see it's 8, 12, 18, 27, 40.5. Wow. We can see that they are growing at an increasing rate. Okay? If we try to get the rate of change, let's say rate of change, like 12 minus 8, we have 4. 18 minus 12, we have 6. So this is 4, this is 6. 27 minus 18, that's 9. And then 40.5 minus 27, that is 13.5. All right? It's not even, the rate of change is not even constant. So there are only 2 types of function we know of with a variable rate of change: a quadratic and exponential. So we might think about, is this a quadratic or exponential? But a quadratic will have both an increasing and decreasing interval. But this table only show an increasing interval portion of a quadratic function. It's not in the decreasing. So we need to take a closer look at the rate of change and see if there's only one that we can think about. It might be an exponential function. So an exponential function has a constant percent rate of change. Remember in the characteristics of exponential, has a constant rate of change, constant percent, rate of change. All right. So what we're gonna do here is to get the rate of change in exponential. So we divide 12 divided by 8. It is 1.5. 18 divided by 12, that's 1.5. 27 we divide by 18, we get 1.5. And then 40.5 divided by 27, we get 1.5. Since the ratio of the outputs is the same, ratio of the outputs is the same. Therefore, this is an exponential function. Okay, let's check if this is really an exponential function. Now, actually, the common ratio here is equals to 1 plus the growth rate. if you remember in the exponential function. So, which give us a decimal growth rate. Then we multiply it with, 100%. So in other words, we have 1.5 that would be equals to 1 plus that rate. So 1.5, I mean 0.5, because 1 minus, okay. Move the 1 to the left, that would be negative 1, plus 1.5, you have 0.5 equals R. And you change that to percent by multiplying 100, you come up with 50%. This means as x increases by 1, okay, as x increases by 1, the function of x increases by 50% rate of change. Okay. So we have 1 here, an absolute value function, and this shows an exponential function. All right, let's have question 3. I hope you can remember the piecewise function. You are given more than one function, so 2 or 3 or more. Okay, there are 3 types of function that make up the piecewise function. In this piecewise, what are these 3 types? So we have function of x as x plus 4 and x is less than 0. 2, where x is between 0 and 4, and x is greater than 0 but less than 4. We have 12 minus x squared, x is greater than equals to 4. So these are the 3 types of function. So let's look at the structure of its equation to determine which function it belongs. So the first equation we have is x plus 4. Remember that it is to the first degree, just like in the function of f of x, the slope form mx plus b. So in this case, m is 1 and b is 4. Therefore, the function defines the interval of x less than 0. So this is a linear function. Okay, this is linear. How about the second one? You have in the form of, you have 2 and then 0, x is greater than 0 or equal and less than 4. So 2 coming from in the form of, remember this form, f of x equals c. C is the constant. That's a constant value, which is 2. So the function defines the interval of 0, x is greater than 0 or equal to and less than 4. Therefore, this is constant. Okay? Is constant. The third, you have that's 12 minus x squared. and x is greater than equals to 4. So you see that squared is very clear when you see that. You know already it's quadratic. So let's discuss this. Ax squared plus bx plus c. Remember, this is the form of the quadratic equation. So in this case, a is 1 and b is 0. You have no constant, and b, you have no middle term here, and c is 12. Okay, so therefore, the function defines the interval that is x greater than or equal to 4. So this is quadratic. Okay, the third one is quadratic. Okay, so much so with this, if you try to check, you want to check and see how the graph goes. If you look at the graph on the left side here, we may have mistakenly, by looking at the graph, classified the function. Note that the linear function could have an absolute value function. So this is the constant here, where that the y function is equals to 2. Okay, the function of y equals to 2. And the other one has been a part of absolute value and a piece of quadratic function. This one right here. Okay, so this is why it's important to consider the multiple features of the function instead of relying on the graph alone. All right, let's summarize. Constant, linear, and absolute, okay, functions have a constant rate of change, while the quadratic and exponential have a variable rates of change. In quadratic, might be increasing or decreasing. Exponential is increasing so fast. Although the average rate of change for an exponential varies and it grows or decays at a constant percent rate of change. So the rate of change structure of the equation and the shape of the graph, okay, can help us classify the function into the correct family. All right. So this video is only about the function families. Well, the second part of the transformation will be the transformations and all types of transformations. Okay, we're gonna do that in the next video. So let me say this: if I can do it, so can you. Okay, don't forget to hit the like button and subscribe if you haven't. See you in my next video.